Hello everyone, this is Ramakant Gupta. I have total 17.5 years experience in IT industry. I am currently working as a senior engineering manager, a full stack developer and a solution architect. So we have already started a series where we are discussing about the Java related interview question. This is second session in the series of Java interview questions. So today we are going to understand HashMap. What is a HashMap and what is the internal structure of the HashMap? All those details we are going to discuss in this today's topic. So let's go and understand the agenda for this today's topic. So in agenda we are going to understand the internal working structure of the HashMap, the memory management for the HashMap, and some of the tips to optimize the HashMap. Okay. So what do we understand by the HashMap? We know HashMap is nothing but a data in key value pair. So there is a key and against that key there is a data we store. That's what we know. Okay. These are some of the components which are most important to understand about the HashMap. Okay. So let's go to the example. We create a simple HashMap. What we do? We create a HashMap map we say, and the first part in the generic is a key. So we can define key is any data type. I am saying the key should be of data type string. Again the data can be string, integer, anything. Okay. So here I say word details, word HashMap. Like this I created the HashMap. Okay. Now here I have created the object of the HashMap and I have not defined any size of the HashMap. If we don't define any size of the HashMap, so what happens internally in the JVM? What JVM does? It creates an array of bucket. So what is meant by array of bucket? So this is nothing but a array of bucket, and it internally creates a size of 16 bucket. Each row in this array is called a bucket number. So this row in the array is a bucket number 0. This is second. In the series it will be array of 16 buckets. So initially by default, if you don't give the size of the HashMap, by default a array of 16 bucket size will be created into the memory. Okay. Now so we understood what is a bucket and what is a bucket number. Okay. Now next thing, in this bucket the actual data resides in the form of node, and this node is nothing but a linked list. Going forward from Java 8, it could be linked list or tree node. Now a question like how going forward Java 8 stores this data initially as a tree node, and later on it converts into the initially it is stored in the linked list and later on it converts into the tree node. We'll see that all this information going forward. Okay. So we understood what is a bucket. Now next is the hashing. Now let's go. Now I created this HashMap. Now when I try to put any data into the HashMap, what we do? We use the object of the HashMap and use the put method. Okay. In put method we have to specify the key. I will say like hello, suppose that this is a key, dictionary word. So any description, dictionary hello word. Okay. So what HashMap does, or what Java does for this key, it try to find out the hash code value, and using the hash code value, hash code is nothing but an integer value. Using the hash code value and the size or the capacity of the HashMap, it try to find out the index number where this data will reside. So suppose that using the hash code and the capacity of this array, it identified the data is going to reside into the bucket number 0. So what it will do? It will simply put the data over there. Okay. Now I told this data reside in the form of linked list, and we know linked list has two parts. One is okay. 1 second. Okay, so basically there is a one part is a data and other part is a reference. It's not coming. 1 second. Okay, I'm not able to, but let's understand. It's a one part is a data and another is divided in two parts. One is a data and another part is a reference pointing to the next node in the linked list. Okay, now, okay, so this is simple example of my hash map which I am storing. In this, my key is a string data type, a string object. Now there is a possibility that I can have the key as my custom object also. Just like employee is my class, right? I want to store employee as a key, right? And the data is a string. Okay, so how hash map behave for such scenario? What hash map does, basically what when you try to put the data into the hash map, what Java does, it checks for this custom object if you have defined any hash code and equal method. If you have defined the hash code and equal method, then Java uses this hash code and equal method for its internal processing. If you have not defined, then Java uses its internal hash code and equal method processing, right, for its processing. Okay, so here I have defined hash code. So what Java does, it uses this method to find out the hash value for that key. Okay, and based on that it identify what is the bucket number where this data is going to reside. Now let's say this is the data, the employee data is John. Okay, okay, now employee data is John. Now again, if I try to add one more row, let's say John and any other detail like John family details like this. So when you try to add this row into the hash map, what Java will do, it for this custom object, it will try to it will use this hash code to find out the bucket number. Okay, it found out the bucket number is a 0. Okay, and then what happened, it tries to see, okay, there is already some data residing into this bucket, right? So now what Java does, it uses this equal method, and checks whether the data which is residing having the same key with one I am trying to add. If it is having the same key, how it identify whether the same key, using this equal method. So in this equal method I am saying, if some formula I have defined, what is the formula, on what basis I can say my custom object is equal. Okay, so here if it finds that the data I am going to store is same as the data already stored, so it will replace that data. Okay, so this we understood that what is the use of equal and hash code. These two are important method when we have a custom key or custom class as a key, right? This is one of the, if you don't use the custom if you don't override this hash code and equal, then by default Java uses its internal hash code and equal. In some other video we'll understand the rule of this the contract of this equal and hash code. Okay, so let's proceed further. Okay, now we understood the hashing and how the index number will be calculated. Next is a node. As I told, each data in this hash, in this bucket, is called as a node. It's nothing but a linked list node. Okay, next is a load factor. Now what happens when you keep storing the data into this array list? If you keep storing the data into this array list, initially as the size of this array list, our array of bucket was having 16 size, right? So once it reaches the load factor, the load factor is 75% of the size. So 75% of 16 size comes to 12%. 12 number 12, right? So when you keep adding the data, and when you try to reach at the point that is beyond the 75%, that is when you try to add 13th data into this array list, so what happened? What Java does, Java resizes this hash map and resizes this array of bucket to its double size. So when the resizing happen, it increases the size of this array of bucket to its double. So initially the size was 16, it will resize it to 32. Similar way, when you keep adding the data, and if the load factor, if the number of rows in this area bucket reaches beyond the 75%, again it will resize the area of bucket. So from 32 it will become to 64. Like this it happens. One most important point to remember about this: what happens when the resizing happens? Java has to calculate the index number of all those keys which I have stored. So now let's imagine if we have thousands of rows or thousands of data stored in the hash map, right, in the area of bucket. So if during the resizing, if it recalculates the index number for all those data, so it will obviously be a performance impact on the Java. So this is one of the point to be noted. We will discuss in more detail for the tips how we can avoid these things. Okay, so we understood the load factor, we understood the resizing. Let's go for the collision handling. Now what hash code says, whenever you try to calculate the hash code of any data, and any number of times, whenever you try to calculate the hash code of any data any number of times, it will always return the same hash code value. But the catch over here is like, it does not guarantee that two different values can have the same hash code. So let's take one example. Suppose that you are trying to add one more data. Let's say Adam you are trying to add. Okay, this is Adam employee, this is key I am trying to add, and this is the data I am trying to add. Now what Java will does, Java will try to calculate the hash code for this. Okay, now while calculating the hash code, suppose that it has found the hash code value same as the hash code value of this John, right? Since John is residing into this bucket number 0, and while calculating the hash code of this Adam, it find out the same bucket number 0. Okay, since already the data residing into the in this bucket, so what Java will do, it will check whether the key value, using the equal method, it try to check whether this object which I am trying to, this key which I am trying to store is already having the same value which is residing into this bucket. Since the key is different, they are both are not same, right? So what Java will does, so due to collision, what Java will does, as a linked list, it will try to add a new node, and this John will start, this node will start pointing to the next node. And now here there is no pointing, so here the node reference will be null. So here let me say Adam. So when the collision happening, collision means in this bucket there is already data residing with some key, and you are trying to add data with some other key, right, in the same bucket. So due to the collision, and Java handle the collision using the linked list, it adds the node next to next, right? The next node will previous node will point to the next node, like this in the series. Okay, so this we understood how the collision is being handled. Okay, now treeification. Now what happens, suppose that you keep adding the data, and the size of this bucket, the number of data in this bucket reaches some limit, and that default limit value is 8. In the sense, in this bucket if there are 8 number of nodes, so what Java does, it converts this linked list into the tree node, and that's only from the JDK 8 plus onwards. Before there was no such facility. Why Java converts that linked list into the tree node for the better performance? Okay. Because if the number of nodes is going to increase, so if you have tree node, it becomes very easy to search across the tree node. Okay, so now we understood this point. Now let's go to the null key and values. In HashMap, only one null key is allowed. We cannot have multiple null keys. Okay, so that's all. So let me just say this example here, or let me just take the employee example itself here. Okay, okay, here if I try to add null, okay, why I'm saying like only one null key? Here if I'm trying to again add one more null, so when Java try to add this null key, it matches the key value, and because the same key value is there as the previous one is stored, so it will obviously override this null key, right? This key obviously it will lie. So that's the reason we're saying in HashMap only one null key is allowed, and number of null values can be anything. Just like here I can have null value for this key, I can have null value. Null. Again for this I can have null value. That's fine. Null. So we can have any number of null values, but null key can be only one item in the HashMap. Okay, let's proceed further. Okay, adding element, we understood how hash code and equal method plays very important role for adding an element. We already understood, right, this scenario. Hash code is used to calculate the hash code, and using the hash code it will calculate the index number or the bucket number in which the data has to be residing, and if there is already some data residing into that bucket, so using the equal method it try to check whatever the key I am trying to store, whether the same key is available. If it's the same key available, then it will override the key. It will override the previous node with the new one. Okay, so this is for adding. Similar way for retrieval. So retrieval, how we do retrieval of data? We do a simple way, employee dot get, and here we write this key. This key we write. Okay, this is the key. Okay, so with this what will happen? It will calculate the hash code, and using the hash code it will calculate the index number, and then it will land to some bucket number, and from that bucket it will fetch the data. Okay, removal of data, again removal of data is same way, same processing, it just remove, and that's it. It will remove the data from the HashMap. Okay, this we understood. Now let's understand the performance factor. What HashMap says, if it's a good situation or there is a no collision, in the sense in a particular bucket, just like for this bucket there is no collision, so the time complexity will always be 1. But let's understand the worst scenario. What would be the time complexity? In the worst scenario, the time complexity will be the number of nodes available into that bucket number. So in this case the time complexity will be 2, because what Java has to do, it has to travel across the node to find out the key which you are trying to withdraw. You want to withdraw the data, or you want to fetch the data. Okay, better hash code and equal collision. Okay, so let's understand the performance factor. As I told, when the resizing happening, the Java has to recalculate the index number for all the keys, right? Now let's suppose a scenario, there's thousands of data into the area bucket. Okay, and if the resizing happening, so Java is calculating the index number for each data or each key, right? So for calculating the index number or bucket number for each key is obviously a performance degradation for the Java. So the suggestion is like, if you already know how many data is going to reside in your hash map, or how many data, what would be the initial size of the hash map, so you better define that number of a size of the hash map, right? So that you will save from the resizing, and if you save from the resizing, obviously the recalculation of index number for that key will not happen, and it will improve your performance. This is thing. Okay, let me go to the next thing. Now, in case you want to see the hash map information from your JVM, right? So one of the tool we know, that is a visual VM. What we do, let me show you. Let me run this code. When you run this code, here you start your visual VM, and here you will be able to find out your process ID with which you want to attach your visual VM. Okay, so here just double click over here, the process ID. Okay, go under the monitoring. Under monitoring there is a heap dump, so click on the heap dump. Okay, so here HashMap is residing into the java.util, and this is the HashMap class. So you just click over here, double click over here. Okay, you can see in your JVM memory how many HashMap is being created. This all may not be yours, because Java also uses the HashMap for its internal processing, right? So there may be some nodes which is used by Java, but we have to find out which is ours. So you can click the field, you can click the preview, you can click field, you can click reference, and all this hierarchy, all this information you can click. Okay, let me just find out which is mine one. So just let me roll over. So you just see the key, you just try to see key. Our key is a EMP class or EMP object, right? So this is not ours. Let me just quickly keep navigating. It will take some time to find out, because there are a lot of hash map which Java itself has internally used for its internal processing. So there are literally lot of, see, there are a lot of hash map. Okay, so yeah, so what I have done, I have already taken the snapshot, the data. So let me just quickly show you. Let me just see whether in this I will able to get or not. Okay, all these are internal. Okay, no. Okay, so let me just show you from my demo itself. Okay, so here if you see this hash map, in this hash map I was able to find out my my hash map, and here you will see lot of information which I was talking about. I was talking about load factor, I was talking about size, how many size, or what is the size of my bucket, right? What is the size of bucket? So here 6 crore 54 lakhs, right? Or 65 lakh 4,791. This is the size of my bucket, because I when I was preparing this video, I have did a lot of for loop and try to store the data into the hash map. So that's the reason. So all those information you can see. What is a treeification, minimum treeification, all those information you can see from the this visual VM. So this visual VM will help you to understand your hash map, how many nodes has been created, or what is the size of the hash map. All those information you can see over here. Okay, let me go to the next. Okay, so that's it. I wanted to show you guys about this hash map. If you really like this video, please do like, subscribe, and share this video. Thank you all for joining the call. I'm planning to show you the GC related information as a interview questions. So keep watching and be tuned for the next video. Thank you all.